Means we have completed till over here. Like we are doing Archimedes and then we did this oscillation problem and this floating and all. We move to some little bit of tedious kind of problem. Means they will have a greater understanding. And that's- okay. And usually they have a little bit of great questions. Okay, so you'll solve it and then you'll have to do tell me the answers within 2 minutes. Okay, should I start? 1 minute. So let us take a container. Okay, and this container I fill it up with some liquid. Okay, and the point is in this I placed one cone. Okay, in this I placed one cone of some thickness. Yeah, attached with a thread from a vertical wall. The point is atmospheric pressure is P naught. Atmospheric pressure is P naught, and the height from top level of the water surface to the level of cone is H1. Okay, is how much? H1. But it is said that this cone is a solid cone. Okay, and a solid cone having radius R and height H. Okay, and density sigma. Yeah, at height H, and density sigma, where sigma is less than rho, where rho is the density of liquid. Okay, so this is the condition given, where rho is the density of liquid. The question is very simple. What it is asking is to find the net force. Find the net force exerted by liquid on curved part of cone. Exerted by liquid on curved part of cone. Yeah. Hmm. Tell me fast. So this is my phone. Okay. Now look over, see this. What it is asking, find the net force exerted by the curved part of the liquid, the curved part of the cone. Okay. अरे भाई तो सिंपल सी बात है. There are, if you look over here on this cone, there are two forces which are present. One force which is present from the upper surface of the liquid, isn't it? I call it as F1. And another force is which will be resultant of these normals. Once again, the horizontal will cancel and what will be left? Only top one will be left, isn't it? So the next force is, let's suppose if I consider an imaginary circular surface over here, then F1, F2, which is from all the parts of the cone due to these normals, this is going to be my F2, isn't it? And you know that whatever happens, if this, see, I can't write this in terms of tension or mg, because see, I can't write this whole equation in terms of mg, because on this cone one extra force is present, which is tension t, which is trying to balance mg, and then there is buoyancy force fb. Yeah, so if we try to write that equation, that is totally different. It will not give you the force exerted by the cone force of the curved part of the cone. But we, one thing we know, that the total total force by liquid, by by pressure of liquid is exactly equal to buoyancy force or not? Yeah. So it will be what here? F2 minus F1 must be equal to buoyancy force. Why we will consider mg? If I am, this buoyancy is generated by the pressure differences force equations or not? Are you able to get me? So this is why it can be considered directly. So F2 is what? Nothing but the, you can say, I have to find F2, isn't it? So F2 minus F1 is what? Nothing but pressure, total pressure into area of the base area of the cone. So P naught plus uh, rho GH, rho GH1, isn't it? Into area is how much? Pi capital R square. This is my F1. While buoyancy force is what? Nothing but rho volume immersion is 1 by 3 pi r square h into gravity. Are you able to get me or not? So what is F2? F2 is a very big equation. It is rho pi r square h g h g by 3 plus p naught. इसको सॉल्व सिंप्लीफाई कर लेना तुम खुद से, ओके, इफ इट कैन बी सिंप्लीफाइड, pi r square. This is my net force on curved part of the cone. Are you able to get me or not? Okay. No. And net force is this F2. It is asking, net force is F2 minus F1. But uh, just, sorry, try to understand the question. It is asking net force exerted by the liquid on the curved part of the cone. Only on the curved part it is asking. Net force is F2 minus F1, which is the total sum of curved part force minus base part force. Are you able to get me? Okay. Let us do one more question. बोल रहा है I have a container. Okay. In this there is a liquid, but I have two different liquids in this container. Okay. One is of density rho and another one is of density twice rho. Okay, this is my liquid A and this is my liquid B. In this I put one cylindrical block. Okay, they are just means liquid A and B. Okay, I put it two cylindrical blocks. Okay, means a cylindrical block inside that. Okay, I put it the cylindrical block inside that. Take, and the condition is the cylindrical block have height h, total height h. Okay, and density 5 rho by 3. How much is that? Yeah, and this cylinder is in equilibrium right now. Right now, this cylinder is in equilibrium. Okay, so the question is find the find the height in the respective liquid. Let's suppose in this liquid if it has another height, and in this liquid if it has another height. Let's suppose this is H1 and this is H2. So first question is find H1 and H2. Yeah, this cylinder is in equilibrium right now. Second question, force exerted by liquid A and liquid B on cylinder. बताओ, if atmospheric pressure is P. बताओ, you have last 2 minutes left. चलो ध्यान से देखो. One of the most important thing to solve to understand this question. अच्छा क्या दिमाग लगाओ अगर मान लो निकालना है H1 और H2, दिमाग क्या लगना चाहिए? F net is equal to mg, correct? Buoyancy force is equal to mg, but how many buoyancy forces are there? That's the biggest thing to understand over here. Okay, so first thing first, see, there is a force from the upward liquid, isn't it? That will be balanced by some force from the downside, isn't it? So I call this, let's say this is force 1 and this is force 2. And then the equation should be what? You only tell me. What should be the net force equation? Okay. F2 minus F1 is equal to, is it going to be that? Yes. So you have F2 minus F1 is equal to buoyancy force Fb, isn't it? Are you able to get me? And what it is asking, find H1 and this Fb is only equal to, if it is in equilibrium, that means buoyancy force is equal to mg, isn't it? Yeah, so F2 minus F1 is equal to mg. If I, so you can put that and you can get the answers, isn't it? 1 minute. But that will be only providing us the answer of, this is the answer of second question, that force exerted by the liquid A and liquid B on the cylinder, isn't it? So F2 minus F1 is what? Nothing but the force exerted by liquid A on B or B or on A, isn't it? So that is your direct answer. Are you able to get me or not? Yes. So point is, no, we will not be able to find out. How come we can find it out? Then what is H1 and H2? How to find out? We will consider only the, think once again. So how come we can find H1 and H2? That's the biggest question. Or we have to definitely calculate basically H1 and H2. Hmm. So how to calculate H1 and H2? See this. If I want to find, it is asking that find H1 and H2. So nothing, just consider that, let's suppose if I can write the pressure difference equation on both the surfaces, then I can definitely write the particular, like if I can write the pressure difference equation, then only I can get H1 and H2, isn't it? So let's suppose if I want to write the pressure difference, now you think of one case. Let's suppose there is a object inside the container. Okay. So let's suppose if this is my body till this level, till this liquid level. Okay. Where is buoyancy force is acting? Upwards. Sorry. You see that for this, this if this block, this is like a, just like a sinking body in this particular liquid or not. But for body B, it is a floating body, isn't it? So which one is bigger? Mg is bigger than buoyancy for this part. Yeah. I'm just trying to divide the two cylinders. Okay. Now look for the second cylinder. For this, whatever is the buoyancy force, that is more than mg, isn't it? But buoyancy force will be only equal to 1 or not. Like let's suppose if this is buoyancy force by cylinder 1 and this is buoyancy force by the cylinder 2. So buoyancy force by the cylinder 2 is helping the mg to be lifted up. But here the buoyancy force is although less for the second cylinder or not. But whatever happens, this buoyancy force must be added such that to balance my mg, isn't it? Are you able to get me now? So there are two buoyancy forces on the over this layer over here. Are you able to get me? I'm considering about this layer. Is that clear? So it gives us the correct idea to understand, and that is why let's suppose if this is buoyancy force 1 by the cylinder 1, buoyancy force 2 by cylinder 2, that must be equal to mg. Is that clear? So buoyancy force by cylinder 1 is rho g into height H1, isn't it? Total height emerged into area of cross section A. Is that clear? That's my buoyancy force by cylinder 1. Second cylinder, I can write H2 as what? H2 as total height minus H1, isn't it? So this one will be, this one is in twice rho density of the liquid. So twice rho G, height H minus of H1 into area of cross section A is equal to mg. Mass is nothing but density. Density is already given 5 rho by 3. Rho mass area into volume, density into volume into g. So ध्यान से देखो a a a everywhere got cancelled. G got also cancelled. What I'm left with is rho h1 plus twice rho h minus twice rho h1 is equal to 5 rho by 5 rho h by 3. Rho and rho will also get cancelled, isn't it? So you will be left with twice h minus of h1 is equal to 5h by 3, and if you just interchange, what I'm going to get, it is h1 is equal to h by 3, and this implies if h1 is equal to h by 3, this implies h2 is equal to how much? Twice h by 3. Are you able to get me or not? Did you got the idea? Whenever you have this kind of composite kind of problem, always follow the procedure of the interface, that whatever happens, buoyancy force is only going to minus mg. Then if there are many compositions, then there will be many different such buoyancies, because every body will have different buoyancy force. And you know that the buoyancy force acts at the center of the body. So whatever is there, you can just find out that the net buoyancy force Fp is working at the center, but there are two buoyancies which are due to height h1 and h2 respectively, and we just added them and made them add to be equal to mg. Are you able to get me? Okay. ठीक, दूसरी बात, F2 minus F1, you can write the F2 minus F1 pressure equation, okay, and then you can get the value of F2 and F1. Like I'll show you 1 minute. F2 minus F1. What is F2? If you look over there, see what is F1. Let us just, you will have to consider that this height is just a height y. Okay, this height from here to here. Okay, if that is y, then F2 is like I'm measuring from here. F2 is P naught plus rho rho gy, isn't it? Rho gy, that is my F plus, after that rho gh1, isn't it? Then twice rho gh2, that is my pressure for F2. That is my pressure for F2 over here. Okay, and that multiplied with area, this is my F. Similarly, if I can put F1, F1 is nothing but P naught plus rho gy into area A, and you can put it P naught A F2 minus F1 plus rho gy. You have the height, you got the height H1 and H2 now. F1. F1 is on this top surface or not? So how come it will be having H1? It will just be equal to rho gy. So you can put it equal to, means if you can just put it from here also, you can get H1 and acha, I can here I can get also H1 and H2 from here also. Okay, like just by putting F2 minus F1 is equal to G mg. Yeah. Okay. Is that clear? Okay. Now let us move to next point. One more question. बोल रहा है there is a container. Actually, fluid mechanics. That's why Acha, after 2 days, I'll start rotational mechanics directly. Okay, means first collision, then center of mass, then rotational mechanics. Okay, I believe so. I believe so. I can't be so sure. Yeah. Next time, I'll do what? I'll just put the question paper over here. I'll not write it. I'll just put the questions all prepared already. Okay. Now look over here. There are two blocks. Okay, means two spherical balls which are attached like this way. Okay. Got it. The question is, let's suppose, and this particular thing, this is a string over here. Okay. This is two balls. No, no, not equal masses of same volume are in equilibrium as shown. Okay. First question: compare sigma. If they have, let's suppose, the densities are sigma one and its density is sigma two. Okay. Then compare their sigma. Compare sigma one, comma density rho and sigma two. Second, find relation in sigma 1, sigma 2 and rho. Third, find tension in string. Check. The density of liquid is represented as rho. Okay. And this is my string over here. Okay. Hmm. Atmospheric pressure is P naught. बताओ जल्दी से बताओ. Hmm. What should be the condition of sigma 1, sigma 2 such that they can be arranged in this fashion? अच्छा एक बात बताओ पहले एक सिंपल सी बात बताओ. Which one is floating upward, sigma 1 or sigma 2? So sigma 1 is definitely less than rho. Sigma 2 is going down or not? So sigma 2 is. But this is your comparison between sigma 1 rho and sigma 2. Isn't it? Next thing, whatever happens, you know that force of buoyancy must be equal to mg or not. There are two different bodies. FB1 is equal to, there are two different masses. Was, are you able to get me? Because for both of them, see that for this also buoyancy force is upwards. For this also, है ना? Mg is, this is M1g. This is tension is getting cancelled now for both of the system. Hmm. Are you able to get me? Now, force of buoyancy one will be what? Rho into uh, volume of the object into gravity g. Rho into volume are same. So buoyancy force will be also same, isn't it? Because volume are same on both of them. M1 is sigma into volume into gravity z plus M2 is sigma 2 into volume into gravity g. Are you able to get me or not? So what do you got to know? That this V and G and V and G will cancel and sigma 1 plus sigma 2 is equal to twice rho. So we got the idea that the density required to have such a kind of condition must be always sigma 1 plus sigma 2 divided by 2, which is equal to average system density. मतलब अगर कोई पूरी एक सिस्टम है उसको फ्लोट करवाना है तो उसका एवरेज डेंसिटी के बराबर लिक्विड की डेंसिटी होनी चाहिए. Are you able to get me? Now I have to find the tensor in the string, isn't it? So look over here, how the tension will work. So for block 1, the tension is downwards, isn't it? For block 2, the tension is upwards. So the equation will be simple. So they are equally opposite, so they will cancel. But I can still write now. So FV1 minus tension T is equal to M1G, isn't it? And here FB2 plus tension T is equal to M2G. Are you able to get me or not? So it's 1 minute, 1 minute. Let's not go to that because I have to just find tension. One equation I require. So FB1 you know that is rho into V into gravity G minus tension T is equal to mg sigma 1 into V into G. Are you able to get me or not? So so tension T is nothing but rho minus sigma 1 for block into V. Yeah, you can even write that same equation, but that will be in terms of that will be for sigma 2. It is it's not always rho minus sigma. You see that for sigma, hmm, it will be sigma 2 might no 1 minute. FB2 plus tension T is equal to M2 G. Yeah, sigma 2 minus rho into Vc. Vc. Yeah, is that clear? So both are correct. Both of the tension are equivalent and they are correct. Okay. Okay. One. Hmm. What? That's what I said. Yes. Both of them are possible. Okay. Now look over here. One more container. This is the last container. Okay. I filled this with some kind of a liquid. Okay. And in that, I placed one rod. Okay. 1 minute. Let me just. Yeah. Now in this, I just placed one rod. Okay. Now that rod can rotate. Got it? My goodness, that will not become bigger. Yeah. Okay. So there is a rod, okay, which is attached in this liquid. 1 minute. Let me just erase some part of the liquid. Okay. So I have this rod which is attached, and this rod is trying to rotate over here. What it is trying to do? Rotate. Okay. Yeah. Now look over here. See, what is the condition? That when it is trying to rotate, okay, the condition is you have to, when it is trying to rotate pole rack, at that time, at that instant of time, it was making some kind of angle theta with respect to the one side of the container. Okay, and this is my O, origin O. The liquid label is of height h. Okay. The question is, let us write the question fast. The question is, a wooden rod of length L and density sigma, and such that sigma is less than rho. Then find the angle theta. Then find the angle theta made by rod in equilibrium. And find the angle theta made by rod in the equilibrium. It's a very awesome question. It's not only you need. Do you know about torque and all? Okay, so it's based upon torque. Okay, rotation is always based upon torque. Try to balance the torque because it is in equilibrium. First thing first, you see this. Is this rod is stationary? It's not. Now it's not rotating. You see that it's find the angle theta made in equilibrium. So this rod is neither rotating neither translating. So it is in both. Remember that when the body is in both uh, translational and rotational equilibrium. So first task is you have to do the net force to be equal to zero for translational equilibrium. Yeah. Translational equilibrium means the body is not moving here and there. And second thing is you have to check for the rotational equilibrium. For rotational equilibrium, torque net should be zero, but you have to confirm that body is even not rotating. And here we have both. So you got the easy question. Okay. Because it poses both conditions, it can be easily done. Okay. Now look over here. Let us just see this. Let us just first make a triangle of this rod. Without making triangle, you can't get anything. Okay. Now let us suppose if this is triangle and this is height h, isn't it? Wait. So how much? Let's suppose if this from here to here. Wait. No, that is also height h only. Na same. So I want to find that how much of the length of the rod is inside the liquid. So if that is h, so I can write in terms of cos theta is equal to this length which is present inside the liquid divided by h. So I can write length of rod inside the liquid is simply H by cos theta is just H sec theta, isn't it? Are you able to get me? So force of buoyancy will be what? And force of buoyancy will work at the geometrical center, isn't it? Geometrical center of whole body or geometrical center of the body, which geometrical center of the region which is present inside the liquid. Center of the region inside the liquid, not for the whole body. Okay, this is the center right now. This is my buoyancy force. First thing first, did you got the idea? Second thing, somewhere around the center of mass, that is for the whole body, somewhere around here, or let's suppose, yeah, let's suppose over here I'm considering. Okay, somewhere around here. Let us just make it over here because my geometry is totally different. Somewhere around over here, the mg will work, isn't it? That's mg. Yeah. So there is a torque, and that is only getting balanced, which is making the body to do not rotate. Are you able to get me or not? Okay. So look over here. Buoyancy force will be exactly equal to rho. Volume of the object immersed is h sec theta into some area into gravity c. यही होगा ना? Is that clear? Next thing, if I think of the weight mg, here volume is measured, length is given. So mg must be written in terms of sigma, that is sigma al into gravity c. That's my weight factor. Are you able to get me? Now look over here. If I just think of these cases, if I just think of this triangle, how this triangle has been, or how this triangle has been formed. So you can you just look over here, see this. If I just, I'm just making this triangle over here. Hmm. Sorry. 1 minute. Opposite side, it's same. Now look over here. So there are two factors, mg and buoyancy, isn't it? And this is height h. This is height h. Here mg is working. Here buoyancy is working. Buoyancy force. Are you able to get me or not? Now this is angle theta. Let us just call this radius as, there are, I'm defining two radiuses. Okay. For mg and all from the, or because this is my origin from which it will rotate. So let us suppose this is x2 and this is x1. Are you able to get me or not? Is that clear? So simple. X2 is nothing, but it will work like it is. If I just want to write x2, this base from here to here, it will be L by 2 or not, because mg works from the center of mass, isn't it? Yeah. So x2, I can write x2 into, like we know that the formula is sine theta is equal to perpendicular, which is x2 by base L by 2. So this implies x2 is equal to L by 2 sine theta. Are you able to get me or not? Because for mg, this length is how much? L by 2. Is that clear? And x1, you try to understand x1. X1 will work at the half of the length of the buoyancy force, means half of the length of the geometrical center of the submerged region or not. How come it is L by 4? If this height is, if this length is h sec theta, so how come it is L by 4? Now you got it. So sine theta must be equal to also x1 divided by this length, which is h sec theta divided by 2. Are you able to get me or not? Is that clear? So, so x1 is equal to, yeah, h sec theta into sin theta. Is that clear? So these are your different forces equation over here. Okay. No, how come? Hey, how come? Hmm. So now, this was our force equations, isn't it? This gives us the understanding, and now you can apply that if the bodies are in translational equilibrium or something like that. So I can see there are many things here. There are one force I'm missing over here is that we call it as normal. So here there are two normals. One is normal along x direction, another one is normal along y direction. Okay, so when you are going to write for the translational equilibrium, the net force along the x-axis must be zero. So many people think now that after looking at this diagram, they will just write FB is equal to mg, but that's not true. FB is not equal to mg. Okay, so the first condition that do not write FB is equal to mg over here because I have how many normals over here? Two normals over here. Are you able to get me or not? One is normal along x direction, one is normal along y direction at the point of contact of the hinge. Is that clear? Are you able to get me? And if you do not take normal along x and normal along y, then just take 1 minute. Then just take these components of the normal, that one normal along the body and one normal perpendicular to the body. Are you able to get me or not? So there are two different cases which you can apply, and then you can see. So that is why I didn't apply that FP is equal to MC, because that's not true. Is that clear? Are you able to get me? But always try to solve. Remember that means this is also good, but we usually solve using nx and ny because it makes our question to be easy. So actually, if you look over here, the value of the actual equation is if I take nx and ny, the buoyancy force is Fb plus ny is equal to mg. So this is my whole equation of Fb. Okay. But then once again, you'll have to find nx and ny. So to easily calculate this, we'll do one thing. Since the rod is in rotational equilibrium, since the rod is in rotational equilibrium, what will happen? Net torque will be zero. Net torque about the hinge will be equal to how much? Zero. Are you able to get me or not? So this is why I can write force of like I can write, you can simply write torque is equal to, what is the formula of torque? Torque is equal to force into R perpendicular or F perpendicular into radius, isn't it? So I want to find from here, if I want to find from here, here you know that the perpendicular force is FB, so perpendicular radius will be this one or not, X1. Are you able to get me? So FB into x1, but that thing, try to understand, if you just see that that thing is trying to rotate in which direction, it will rotate anti-clockwise direction, isn't it? And the mg is trying to rotate in which direction? Clockwise direction. So that is why I can write for fb, anti-clockwise is always positive, so fb into x1 minus mg into x2 is equal to how much? 0. So equation becomes fb, hmm, FB, you replace it. FB is rho H sec theta, area A, gravity G. Oh, that's a big question. X1 is L by 2 sine theta is equal to mg sigma AL into G into x2 is H sine theta sec theta by 2. So sine theta cancel, L cancel, area cancel, gravity G cancel, H cancel, sec theta cancel, 2 cancel. Okay, all are cancelled. What is left there? I think I am doing some silly mistake over here. 1 minute, 1 minute. Let me check what I am doing is silly mistake. A 1 minute. X1. X1 is for FB. 1 minute. Hey, X2 is for. Sorry, I just wrote wrong equation. FB is rho H sec theta area A gravity G, that is force, and x1 is actually H sec theta into sine theta by 2, which is equal to mg, which is अरे तो बन गया sigma a l into gravity G into x2, which is L by 2 sine theta. So this got cancelled. Area AL, L will not cancel. AA got cancelled. GG got cancelled. Okay, and then it is 2 and 2 got cancelled. So the equation is rho h sec square theta, okay, is equal to sigma L square by 2. Are you able to get me or not? So you can just put it and you will get it like in terms of, I think here h square is also there. Okay, so sec square theta is equal to sigma by rho, means I think 2 will also get 2 also got cancelled now. So just sigma L square. So sec square theta is nothing, but I'll just write sec theta directly now. 1 minute. So this implies sec theta is equal to sig L by H will be outside root under sigma by rho. That's your answer. That's the angle made. Is that clear? Totally? Hmm. Okay. चलो एक और क्वेश्चन जो सबसे ज्यादा पूछा जाता है, मीन्स यूजुअली इट इज आस्क्ड एंड यूजुअली पीपल आर नॉट दैट मच इसको ध्यान ज्यादा नहीं देते, बट इट इज यूजुअली आस्क्ड इन द एग्जाम्स, and let us see that it is asking that I have two containers. Okay, I have two containers, same width, everything is same. Okay, and I just put it liquids in that. Now try to see. In that, what I did, I put it some ice. Okay, I put it some ice. This is ice. Okay, here what is there, that I have also the ice, but in that there is a stone also. There is a big stone inside that ice. Yeah. Okay. This is water. You know that. This is also water. Okay. Remember, then this is my stone, and density, what it is given, that density of a stone is greater than density of water. Okay. So the question is simple. Compare the height of water surface. Compare the height of water surface after the ice melts. After the ice melts. Nice. Yeah. Think. First think of ice water gas, then think of a stone. Hmm. Yeah. Let us discuss the first case. Think, then tell me what will happen. Uh-huh. Think, reply fast. Acha, ice, if ice is floating, isn't it? Then the buoyancy force is only there for the submerged region. Yes. Then if ice melts, what will happen? It will convert into water. But for water of which reason? That's the biggest thing to understand. But for water of which reason? जैसे मान लो देखो सुन लो ये पूरा का पूरा आइस था ओके ठीक ये आइस था है ना अब आइस का इतना ही रीजन सबमर्ज्ड है ना this much region only. If this much region is submerged, then let's suppose the total mass of ice was m. Let's suppose the m was the total mass of ice. Okay, isn't it? So for floating ice, whatever is the mass of ice into gravity g, that must be balanced by my buoyancy force. But what is buoyancy force? Mass of ice into gravity g is equal to weight of water displaced. Isn't it? This is what was told by Archimedes. So if I if I just mass of ice into gravity g is must be equal to mass of water into gravity g of displaced water, isn't it? So G got cancelled, and what we get to know that mass of water displaced, isn't it? So that means what? That means what? Whatever is the mass of ice over here, it means the displacement of the water is exactly equal to the mass of ice or not. Yes. So if this whole ice just melts and gets submerged, then what it will do? Whatever was the water displaced, this was the water displaced level after it was submerged, isn't it? So that mass of ice will also get spreaded in this water or not. And if it gets spreaded, the water level is going to be same only. Why it is going to be same? Yeah, because The point is that whatever is the mass of ice, and that much is the amount of water displaced, and that is getting melted and it's present inside that. So if it is getting melted and present inside that, then what will happen? The water level will not change. Are you able to get me or not? Yes. Case 2. If it has a stone, what will happen? Tell me. Hmm? Think. Then, then what I will get as equation? So stone will go down definitely. We know that. Then water level should increase or decrease. It should, isn't it? Look over here. See this. Mhm. Acha, there was an ice. There was an ice, isn't it? And inside that, there is a stone. Okay, let's not. Yeah. Now, density of a stone is more than density of. Sorry, density of what? Yeah, isn't it? First conclusion is already given to us. Now look over here. Once again, let's just have one conclusion that stone is heavier than water. I can write it. Yes. The stone is heavier than water. I think about initially the whole system means the whole water level was due to water displace was due to is initially it was equal to mass of ice plus mass of a stone into gravity g. That was my water displaced. Ice melts. Ice will melt, isn't it? So when ice melts, the water level was still that got basically that got similar with the water level which was present initially or not. Yes. Now, as the ice melts, water displaced is due to what? Water displaced is due to just mass of a stone into gravity g. यस isn't it? तो ध्यान से देखो पहले समझो पहले एक बड़ा सा वॉल्यूम था एक बड़ा सा चंक था जिसके वजह से ये वाटर डिस्प्लेस्ड इतना दूर तक हो रहा था है कि नहीं? अब ये चंक पिघल गया अब ये आइस पूरी की तरह से क्या हो गई पिघल गई तो जितना वो वाटर डिस्प्लेस पहले की थी उतना वाटर वो हेल्प करेगी उसको उसके लिए है कि नहीं but at that time what happened actually the stone was circumferenced over here and due to which although its mass was more although its density was more but it was trapped inside the ice so इसकी वजह से वाटर लेवल थोड़ा और बढ़ गया था है कि नहीं अभी अभी क्या हुआ अभी अभी तो स्टोन सिर्फ है ना तो जिसकी वजह से वाटर डिस्प्लेस होगा आइस की वजह से क्या हो जाएगा वो वाटर लेवल में मिक्स हो जाएगा तो बिकॉज द स्टोन इज वेरी वेरी स्मॉल the water level will decrease. It will not increase. It will decrease because the water displacement is only present due to this stone which has started sinking. Are you able to get me or not? And ice water will just submerge it. Okay. It will take the ice down totally. How come the water? अच्छा एक बात बताओ, how come the water level will increase? उस स्टोन के वजह से तो वाटर का एक्स्ट्रा डिस्प्लेसमेंट हुआ था ना। हाँ, अब जब तुमने आइस मेल्ट कर दिया तो जो पहले जो वाटर लेवल था जो कि स्टोन के वजह से था, अब स्टोन क्या करेगा? स्टोन तो नीचे चला जाएगा ना, तो उसके वजह से वाटर डिस्प्लेसमेंट होगी क्या? नहीं ना। तो जो भी आइस वाटर था वो क्या करेगा? वो फैल तो जाएगा बट वो अपने अपने मास के ऊपर सिर्फ डिस्प्लेस करेगा, स्टोन के मास के ऊपर डिस्प्लेस करेगा ही नहीं, है ना। तो इसके वजह से जो डिस्प्लेसमेंट होगी वो कैसी रहेगी? इट विल बी लेस, इट विल बी लेस। आर एबल टू गेट मी? अरे भाई एक बात, पानी भर दिया, ये स्टोन प्लस आइस कंबाइंड है ना। ध्यान से देखो, अगर सिर्फ आइस रहता तो वाटर लेवल कहाँ पे रहता? यहाँ पे, है ना। सिर्फ आइस, आइस प्लस स्टोन, आइस प्लस स्टोन में क्या हुआ? वाटर लेवल ये है। समझो समझो, this is only ice, this is ice plus stone due to the increase in the mass of the stone, isn't it? समझो। and after that it melts. So ice if it melts, ice will come to its own level or not, which is this level. And that was actually ice plus stone. Now the ice will come to its own level because this stone is not a floating stone. This stone is which kind of a stone? It will, so it will come down, isn't it? So even for that sinking stone, if it is only alone, it will have a very less displacement or not, which is less than the original displacement. So what do you saw? Water level decreasing. Water level, got it? Is that clear? So in case two, when the stone is there, so remember that, uh, like initially a stone displaced water according to its weight, according to its weight, but finally when all ice melted, all ice melted, the stone gets drawn. Okay, and if a stone gets drawn in water, what will happen? The displaced water will be just equal to its volume, isn't it? Okay, so displaced water is equal to its volume, and that is why water level decreases because its volume is very very small. Are you able to get me or not? So uh, remember that. Just if you remember, if any object inside ice is heavier than water, ठीक, then if ice melts, water level always decreases. Water level always decreases. Are you able to get me or not? So you can जैसे एक एग्जांपल लेके मैं बता देता हूँ, ठीक है? मान लो कि एक स्टोन दिया हुआ है ना? उसकी डेंसिटी है 3 रो एंड वॉल्यूम कितना है V, ठीक? And rho is the density of water. So look over there, it has a higher density now. Means that's what I'm saying. A stone has a higher density. Now, when the stone was floating in the ice, अरे बाबा, आइस के अंदर क्या है? अगर अरे बाबा, तो that is was stone was floating. I am writing stone was floating, not ice. Means it is only floating when it is trapped inside ice, isn't it? So buoyancy force will be equal to how much? Mg. And what is my buoyancy force? So rho into volume immersed into gravity g. What is m? That is density of the stone, which is 3 rho into volume into gravity g, isn't it? So rho into volume immersed into, अच्छा इसमें तो कैंसिल यहीं पे हो जाएगा, तो ध्यान देखो, रो 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 कैंसिल हो गया, जी जी कैंसिल हो गया, क्या है? वॉल्यूम इमर्स्ड which is getting felt inside is actually thrice time of original volume, isn't it? So water displaced will be what? Thrice of the original volume. But when it starts to get drawn, what happened? The displacement, water displaced for sinking a stone, for sinking a stone is how much? It is equal to, just equal to volume of the stone or not. So see that where water displaced is more. In first case, now the water displaced is less, and that is why volume of water, level of water decreases. Is that clear? So so this was all about your Archimedes principle and all. We did good questions today also. So today evening also we are going to sit, isn't it?